We need to identify whether the given series is convergent or divergent. We will use the ratio test here. So before we use the ratio test, let's find the nth term of this series. So an equals n factorial squared over 3n factorial. Well, and n plus 1 equals n plus 1 factorial squared over 3n plus 3 factorial. Well, so now L equals limit of the absolute value of n plus 1 factorial squared over 3n plus 3 factorial, and this whole thing is divided by n factorial squared over 3n factorial, and n approaches infinity here. Then we get that this equals the limit of the absolute value of, let's try to simplify it. We would get n plus 1 squared over 3n plus 3 times 3n plus 2 times 3n plus 1. And n approaches infinity. Then we take n squared as a common from the numerator and n cubed common from the denominator, and we get that this equals limit of the absolute value of n squared times 1 plus 1 over n squared divided by n cubed times 3 plus 3 over n multiplied by 3 plus 2 over n and multiplied by 3 plus 1 over n. And n approaches infinity. Then this equals 1 plus 1 over n squared. Oh, sorry, the limit. Sorry, I forgot the limit. The limit of the absolute value of 1 plus 1 over n squared over n times 3 plus 3 over n times 3 plus 2 over n plus times 3 plus 1 over n. And n approaches infinity. So we get that this equals the limit of 1 over 27n, where n approaches infinity, so it just equals 0. Since 0 is less than 1, that means that our series